Hello everybody, welcome to this presentation. My name is Haiti, and today we're going to talk about employee attrition analysis with Frito, and we're going to talk about how do we reduce attrition rates. Now here we go. So for today's agenda, we're going to talk about introduction, we're going to talk about what causes people to leave, the actual leading factors that leads to attrition, and also the interesting findings throughout the analysis, and also we're going to give our recommendations to the company to reduce attrition rates. Now, for the attrition, we all know they have all negative effects to the company. The resources are getting cut, skill sets losing, cultures getting disrupted, and also reputations getting hurt. It's harder to hire top talent people in a company. So how do we actually keep people around? Now, first of all, before we actually use the data that we have, then there's a couple steps we need to do to pre-process the data to make sure that they are, first of all, on the same scale, and second of all, that there's no NA values or any outliers, and obviously, third of all, then we have to make sure our categorical variable, and we have to factorize some of the categorical variables. But we do have to understand that not all categorical variables are equal to each other, meaning when we factorize them into 1, 2, 3, 4, we understand the distance between 1 and 2 and 3 to 4 is not equal. And afterwards, we have all the data with all numeric variables. Now, the next step is splitting the data into two and doing hypothesis tests between people who stayed and people who left. So after we conduct the hypothesis test, we can see there's a list of columns and features with p-value less than 0.05. That's our significance level, meaning that there's overwhelming evidence suggesting that that particular feature, a meaning of that particular feature is very different between people that stayed and people who left. And furthermore, the less p-value it has, meaning that there's more significant, more evidence suggesting that the mean of that particular feature is very different from two groups of people. Then what we can do is inferring that into identify those feature and factors as the driving force of attrition. Now, with at least 3 p-value or the top 3 factors that we identified here is obviously first the marital status and also monthly income and overtime, and those 3 factors are going to be what we chose to be the top 3 factors driving attrition. Okay, moving forward, after we've done all the hypothesis tests, we have obtained all the columns and features that are deemed significant. We're going to use those features and columns to fit our models here now. The first one we choose is KNN. It's using the Euclidean distance to calculate, to classify the K near its neighbor as the classification results. Now, we've ran this test thousands of times. There are 3 hyperparameters we're going to be tuned here. Sample size number 1, K from 1 to 50, and also threshold from 0.1 to 0.9. We ran this iteration for 45,000 times in total with a 70% and 30% split. And we found out that optimizing for AUC value here, which is also optimizing for both sensitivity and specificity, we got the best AUC area under the curve around about 0.8 to 0.9 here. Those are the hyperparameters we're going to be using when we're choosing those models to predict future data sets. Same experiment, just different visualization here. As K goes up, we see that as threshold goes up as well, we get the best average performing AUC value here, and we get the best iteration around 60,000 times 874 here with AUC at 0.82 with the best K at 25 and best threshold at 0.8. Now the second model that we choose is KNN.CV just to see if there's any meaningful difference between the KNN.CV and KNN. Similarly here, the best performing results at iteration 32,000 times here with the best K around 21 and threshold at 0.9 AUC value here and 0.77. The third model we choose is naive Bayes here. Obviously, there's no K to tune, but the threshold is still between 0.1 to 0.9 here. The best iteration is at 5,910 times here, iteration with the best threshold at 0.7. AUC value here is at 0.86. The last model we chose is linear regression here. The linear regression has the iteration at 121 here with the best AUC value appearing at 0.82 with a threshold at 0.3. And on average here, we can actually see the best threshold is roughly about 0.02 here. Now, putting everything together, naive Bayes has the peak performance. The best iteration happened there with AUC value at 0.86. With the number 1 and the best sensitivity and best specificity, but that doesn't mean we have to choose that particular model, because we have to choose the one has the best performing averages, not the best performing iterations. But still, naive Bayes still won, because on average, naive Bayes performing the best when threshold is at 0.6. On average, that's the best performing model that with the best highest AUC value. However, All those models are not very different from each other. You can see that the average of all those performing models with the best hyperparameters are very similar. So actually what we're going to be end up doing is using the best two models here, actually naive Bayes and Kn.CV, to assemble together using majority vote, and after that we can have the best performing, or on average the better models to predict future data sets, and that's what we're going to do. All right, here's some interesting findings along the way. The most satisfied job role actually in the company is going to be the sales representative and also the research scientist. Also, the further away you are from work, the less satisfied you are going to be when you're at work. So, which is very interesting. You have to live closer to where you work to be more satisfied. There's actually single workers are going to be more satisfied when you're on the job. Now, with the attrition, also very interesting with marital status. Single people, however, are going to be more likely to choose a different company under circumstances, which we think is very interesting how these factors are correlated with each other. Also, monthly income seems to be negatively correlated with attrition. So the less money you make, the more likely you're going to choose a different company. Obviously, the total working years, the more years you work at a certain company, the more likelihood you're going to stay there for longer. So there's 6 point of recommendations and suggestions that we're going to make. First of all, obviously increasing monthly income, that's going to keep workers here. Second of all, hire more married workers. That seems to be another factor to reduce attrition rates. Reduce overtime, because overtime we think that is positively correlated with attrition, and also longevity incentive. Also, promotion job level seems to be positively correlated with attrition rates, and we think that foster communication, relationships to increase job involvement can reduce attrition rates. So overall, those are going to be my presentation for today. Thank you so much for taking the time to listen to this presentation. If you have any questions, please let me know with my email there, to shoot me an email for any questions. Thank you so much.